Bismillahirrahmanirrahim. I am Amna and this is sixth lesson of Digital Logic and Design BSIT Semester 2. I hope you people have understood the previous lessons. Today we are going to discuss basic logic gates. The objective of this topic is that you people would be able to explain basic logic gates. What are the logic gates? Logic gates are the fundamental building blocks of the digital systems. The name logic gate is derived from the ability of such devices to make decisions, in the sense that it produces one output level when some combinations of the input levels are present. Now we will discuss some basics of the logic gates. First of all, inputs and outputs for the logic circuit. Inputs and output of the logic gates can occur only in two levels, either high or low, true or false, on or off, or it can be represented by 1 or 0. Truth table. A table which lists all the possible combinations of input variable and the corresponding outputs is called a truth table. It shows how the logic circuit's output responds to the various combinations of logic levels at the input. For example, consider this circuit. Switches are in parallel. Now there are two switches, switch 1 and switch 2. If switch 1 is off and switch 2 is also off, the output will be off. And if the switch 1 is off and switch 2 is on, then bulb will glow. Then the third case is switch 1 is on and switch 2 is off. Then again the circuit will be completed and the bulb will glow. Now the fourth case in which both the switches are on, so in this case the bulb will also glow. Now we will discuss the two cases of the logic, positive logic and negative logic. In positive logic, low or 0 is represented by 0 volts and high or 1 is represented by plus 5 volts. In negative logic, 0 or low is considered by positive 5 volts and 1 or high logic is considered by 0 volts. Now we will discuss the different types of the logic gates. Logic gates have mainly three types: basic gates, universal gates, and special purpose gates. Basic gates. There are three basic gates: AND gate, OR gate, and NOT gate. In universal gates, we have NAND gate and NOR gate. In special purpose gates, we have XOR gate and XNOR gate. Now, first of all, let's discuss the AND gate. An AND gate has two or more inputs, but it has only one output. The output assumes the logic 1 state when both inputs are at logic 1 state. It means when both of the inputs are 1, then the output of the logic gate will be 1. The output assumes the logic 0 states even if one of its input is at logic 0 state. It means if any of the input is at 0, the output will be 0. Let's consider the truth table for the AND gate. Now we have two inputs A and B and one output, that is B. Now the output is equals to A and B. Now first of all consider input A is at 0 and input B is also at 0. Now what will happen? The output will be also 0. Now let's consider another case in which first input A is at 0 but B is at 1. So the output will be 0. So A is at 0, B is at 1 and output will remain 0. Next consider the third case in which input A is at 1, but input B is at 0. Now the output is at 0. And now let's consider the last case in which both the inputs A and B are at 1. Now you can see the output is 1. So in the case of AND gate, the output is only 1 when both the inputs are 1. But if any of the input is at 0, the output is at 0. Now let's consider the 3 input AND gate. In this case, again, the if A, B, and C both the 3 inputs are at 0, the output is 0. And if any of the input is 1, the output remains 0. The output will be only 1 when all the 3 inputs are at 1. So in the case of 3 inputs as well, if all the inputs of AND gate are at 1, the output will be 1. If any of the input is at 0, the output will be 0. Now in this case, we have used a 2 input AND gate, and its output is connected with the another AND gate. In this way, we will be able to get the 3 input AND. Now this is an AND gate IC integrated circuit. Its number is 7408. This is used to perform the AND operation. The device contains 4 independent gates, each of which perform the logic and function. Next, consider OR gate. An OR gate has 2 or more inputs but only one output. The output assumes the logic 1 state when even if one of its input is in logic 1 state. It means that if any of the inputs of OR gate is 1, its output will be 1. And the output assumes the logic 0 state only when both the inputs are in logic 0 state. It means that its output will be only 0 if both the inputs are at 0. This is the logic symbol of the OR gate. A is input, B is input, and this is the output. Next, let's consider the truth table for the OR gate. We have a first case in which both the inputs are 0. A is 0, B is 0, the output is at 0. Next, consider the case in which A is at 0 but B is at 1. Now, in this case, the output is 1. Next, consider the third case in which A is 0 but B is at 1. In this case, output is 1. In this case, both of the inputs are at 1, so output is at 1. So in case of OR gate, we have seen that if both the inputs are 0, then output will be 0. And if any of the input is at 1 state, the output will be 1. This device contains uh, this device contains 4 independent gates, each of which perform the logic of OR operation. So this is the IC of the OR gate. Its number is 7432. A NOT gate. A NOT gate is also called inverter. It has one input and of course only one output. It is a device whose output is always the complement of its input. It means that it will invert the input. If A is 0, its output will be 1, and if A is at 1, its output will be 0. That is, the output of the NOT gate assumes the logic 1 state when its input is logic 0 state and vice versa. Next, we have the truth table of 3 input OR gate. In this case, we can see that the output is 0 when all the inputs are at 0, and it is at 1 when any of the input is 1. Now let's discuss the truth table of the NOT gate. Now we have input at 0, so its output is at 1. Let's consider the second case in which input is at 1, then output will be 0. This is the IC of the NOT gate. Its number is 7404, with the help of which we perform the NOT operation. The device contains 6 independent inverters. Thank you.